All right, hello. We're on unit 7, so this is page 5 of your packet. You need to make sure that you finish up page 4. Sorry, 3 and 4 were backwards. Finish up page 4, get that information done, and then take these notes on page 5. I think everything else is in order. All right, so this is day 1, number 2. Just some basic information, because just sometimes you might see things like this. We've talked about this a lot. Reciprocal identity is when we flip the fractions. And you did this on your test and on the last homework and stuff. So we're flipping the fractions. Sometimes you might see it like this. It doesn't mean it's any different. It just looks visually a little different. So sine is also 1 over cosecant. So that means cosecant is 1 over sine. Just a different way to look at it, that's all. It still means we're flipping the fractions. Cosine is 1 over secant, and secant is 1 over cos. Tangent is 1 over cotangent, and cotangent is 1 over tan. Alright, so example 1. Sine of pi over 6 is the same as, sorry, just kidding, just sine of pi over 6. Alright, pi over 6 is right here. Sine is the y value, so sine of pi over 6 is equal to 1/2. So cosecant pi over 6, it's easier to flip it, so 2 over 1, as we did in last unit, or you can do 1 over the sine value of 1/2, so like this, which means it's top times the flip of the bottom. So I wouldn't go through this long process, but occasionally you might see it like that. Cofunction identity. So this is stuff where we kind of touched on it right at the end of the last unit, where you had the same value. So functions are at the same value at their complement. So this just means a complement. So we're looking, looking for an angle. Angle where they're the same. So sine of 90 minus theta, so sine of some degree measure between 0 and 90 is the same as cosine of theta. Okay, this is just visually, it looks awkward like this. I get that. This is just saying the sine of something like pi over 6 is the same as cosine of pi over 3. So they're the complements. So the complements will always be the same. So look at this. So over here, at pi over 6, the sine value here is the same as the cosine value here. So this is all they're saying. The complements will have the same value. So the cosine of some angle is equal to the sine of its complement. And this is how it goes for all of these. The tangent of some angle is the same as the cotangent of the complement. Cotangent is the same as the tangent of the complement. Cosecant is the same as secant of the complement. And secant is the same as cosecant of the complement. So all you're doing is looking for the complements here. Pi over 6 here is 1/2. So sine value is the y value. Cosine value pi over 3 is the x value at the 1/2. So what you're looking for is these angles are comps. Okay, cosecant at pi over 6. Well, I'm going to take sine and flip it, so I get 2. It's the same as the complementary angle at secant, so that's 2. The tangent of pi over 6, which is sine over cos, is sine at pi over 6 is 1/2. Cosine is root 3 over 2. So it's 1 over root 3, so root 3 over 3. Cotangent of pi over 6 is cos over sine, which is root 3 over 2 divided by 1/2. What did I do wrong? Boop, boop, boop. It goes root 3. I'm gonna have to look at that and I'll get back to you. I don't know what I did. Sine over cos, cos over sine. If you guys figured out, shoot me an email. Sine over cos. Oh, that's what's wrong. These, just kidding. This should be the complement here, pi over 3. Sorry, that's why. Alright, so these up here, pi over 6 and pi over 3, these are complements. This is 30 and this is 60. 30 and 60, and I didn't paste it as pi over 3. So tangent of pi over 6, which is root 3 over 3, is the same as the cotangent of pi over 3, which is 1/2 divided by root 3 over 2, which is 1 over root 3, so root 3 over 3. Aha, there we go. Alright, on the next page, we talked about this too, which is a little bit helpful, so we'll just kind of go through this. Sine and cosine are defined as y. It's for sine and x for cosine. And we use these to find sine of cos and cos over sine. So we know the sine over cos is tangent, which is the same as y over x, or opposite over adjacent still. So all these different things for the same idea. So if I flip it, instead of doing sine over cos, I do cos over sine, I'm coming up with tangent. So that's y over x, or adjacent over opposite. Alright, so the quotient identities are tangent is sine over cos, or y over x, and cotangent is cos over sine, which is x over y. All right, so and just another way to represent this. Some of you, I think I've heard talking about this. So any triangle that you have in here where x and y, and the radius is going to be found by doing the Pythagorean theorem to get this. So x squared plus y squared, square root that is r. So sometimes, occasionally, you'll see them as this. Sine is y over r, cosine is x over r, and tangent is y over x. These are still opposite over hypotenuse, SOHCAHTOA, this is adjacent over hypotenuse. These are still opposite over adjacent. So cosecant is just the flip of them. Okay. Nothing really new, just different ways to see it. A reference angle is the angle cubed by terminal side in the horizontal x-axis. So remember I said always make these angles with the x-axis. So in the first quadrant you would go here and make it here, and you'd have a positive x and a positive y. In the second quadrant, the reference angle, we don't want to make a triangle with that, so we use the reference angle. This is the terminal side. We drop it down to the x-axis. It'd be a negative x and a positive y. In the third quadrant, we go from here to there. We draw the angle out. We bring it to the x-axis, negative x, negative y. And the fourth quadrant would be here to here. We always do a triangle, so it's going to be a right triangle. We can do SOHCAHTOA. We do x and negative y. Okay. From there, so you have all these. From there, on page 7, so finish up these two. So you just want to go plot -3, -7, so you'd be in the third quadrant. Draw a triangle there, figure out the third, find sine, cosine, and tangent, and then do this one. Finish those both up for tomorrow. We'll see you then. Bye.